Welcome. On behalf of the National Transit Institute, I thank you for participating in the Transit Asset Management Principles for Transit Systems with Rail Assets webinar. The National Transit Institute develops, promotes, and delivers training and education programs for the public transit industry in the United States. Our next presenters will be Scott Baker and Bob Peskin. Scott Baker is a Senior Consulting Manager with AECOM. He has extensive experience in investment planning for major transportation systems, business process improvement, strategic, operational, and information technology systems, organizational assessment and review, financial planning for transportation entities, and innovative contracting. Mr. Baker has a combination of national consulting experience on major transit issues and hands-on experience based on years of line responsibility for operations and asset management at San Antonio's Via Metropolitan Transit and Pittsburgh's Port Authority of Allegheny County. He is adept at integrating agency service, project, fleet, facility, technology, financial, and labor relations planning. Bob Peskin is a Senior Consulting Manager in the Transportation Consulting practice of AECOM. Dr. Peskin has 35 years of experience in the areas of transportation financing, planning, and management. He pioneered analytical methodologies in the areas of transportation financial planning, analysis of transportation infrastructure capital needs, and operating and maintenance cost modeling. His work focuses on the application of quantitative information to support transportation decision-making. He works with public agency staff in integrating financial, capital, and operating data from all functional areas, including planning, engineering, transportation, and maintenance. I'll now turn the call over to Scott.
The goal of the two-day course and of this webinar is to get an understanding of asset management theory and methodology, and recognize its value to transit. The methodology that we're going to be talking about is based on a method developed primarily in Australia and New Zealand and spread through the Commonwealth, adopted in the UK in formal standards, and our primary authority is the International Infrastructure Management Manual. The objectives of the course are definitions, which we'll start off with some basic principles. We'll talk briefly about benefits of asset management for transit. We talked on the first series of the webinar about the FTA policies that preceded MAP 21, but the course today, and I want to emphasize that the presentation today is really about good business practices and not about FTA requirements. For one thing, as most of you all are all too aware, the FTA has not progressed towards a conclusion of its requirements. It's on a schedule to issue those sometime in 2014. But the MAP 21 broad goals that were set out are going through the regulatory process, and we really don't know the shape of the FTA requirements. But more than that, the objective of the webinar today and the content of it is, as I've said, good business practices for an approach to asset management that will benefit transit rather than meeting regulatory requirements. And we can only hope that there's a large overlap. And we'll talk some today also about implementation of asset management improvements. So we're going to focus today on the asset management plan process. And again, I have to, it's almost an unfortunate coincidence that the MAP 21 requirements also focus on an asset management plan, but what we're talking about is the asset management planning process that's incorporated into the International Infrastructure Management Manual and that school of thought regarding asset management rather than whatever may be forthcoming from FTA. Again, we could hope there would be some correspondence, but I think there will be substantial differences. I suspect what we're talking about today is somewhat more comprehensive than the FTA requirement will be. And we will also present a case study today on prioritization of capital programs. So with that, I'm going to hand it over to Bob to talk about definitions and principles in asset management.
We'll begin this part of the webinar with a set of definitions and then get into the principles. The most important definition, of course, is what do we mean by asset management? And we present here three different definitions. One that we apply in the two-day course, the NTI course, but two other important definitions, one right out of the MAP 21 legislation, and the other a brief one-sentence description of asset management from the International Infrastructure Management Manual that Scott had mentioned. Focusing on that first definition, which we spend some time talking about in the course, the important thing to understand here is that what we mean by asset management is a process that addresses people, organizational culture, business processes, and systems. We're talking about people in terms of leveraging the knowledge, skills, competency, and attitude of people in the agency staff. The reality here is that transit agencies already know how to do asset management. They already have the skills and the experience to do it. It's just a matter of bringing together the right intellectual resources in the right way. We talk about organizational culture as a way of working with this information and taking advantage of the knowledge that is already contained within the organization. We talk about business processes in that we want to find an optimum way to manage the assets to achieve a desired and sustainable outcome, and to do this at the minimum possible cost. And we talk about systems in that we need to leverage a lot of information to do this. And Laura's already talked about the application of information technology, and we'll be talking about it some more this afternoon. Looking at that first definition closely, we see some very important terms. One is the notion that asset management is strategic. That is, it tends to be longer term in focus and more proactive in orientation as opposed to being short term in focus and more reactive. It is systematic, which implies an orderly process rather than a haphazard set of decisions that might not be best in the long run. We focus on business and engineering processes and the extent to which they support the decision-making process. And again, the important decisions here is how to leverage a limited amount of funding to achieve the best possible result. We talk about quality information and that it illustrates the importance of making decisions using data that are accurate, timely, and complete. We focus on well-defined objectives, objectives that are focused on system performance. A couple other terms that we need to define. One is, what do we mean by assets? Well, what we don't mean by assets is just the financial assets that a transit agency's chief financial officer is focused on. We're not talking about the assets that are in an agency's balance sheet. We're talking about the physical equipment, the infrastructure, the civil works that an agency owns. Its vehicles, its buildings, passenger facilities, administrative facilities, maintenance facilities, information technology, other equipment. And also software, particularly software that is purchased out of the capital budget. The term state of good repair is frequently confused with the term asset management. At the very basic level, asset management is more of a process, and state of good repair is a measurement of condition within that process. At the very least, it's that, and I think keeping that distinction in mind as we go through the rest of the webinar, that will be important. Interestingly, there is no consistent definition of state of good repair in this industry. Every transit agency that we work with, we hear a different definition, and even within FTA, depending on the document that you're looking at, there's a different definition. All of these definitions tend to hinge around the notion of asset performance, and we'll be talking about that a little bit later. The term enterprise asset management system is a type of information technology that assembles information about physical assets, when they were purchased, what they cost to replace, what the renewal cycles are, when the last activities occurred with the systems, and that's integrated with the maintenance history of the assets. There's been an evolution in this software over time, and Scott will be talking about it a bit more later in this webinar. The asset management plan, which is really the central part of the two-day course, and which we'll be talking about a little bit later in this presentation, is a requirement in NAP 21. Transit agencies already have to do some elements of this, in that they have to already be preparing fleet management plans. And there's a lot of aspects of fleet management plans listed here that it's reasonable to expect will be contained in the requirement that FTA eventually will have about expecting for asset management plans, which are required as part of NAP 21. The term capital investment plan is an element of an overall asset management plan. Transit agencies already do capital investment plans. They tend to be a 5 to 10 year look ahead at what needs to be spent. Ideally, the capital investment plan is tied to performance targets and relates to the disciplined long-term strategic view that's consistent with the definition that we've already described. This slide defines 5 major principles for performing asset management. The 10-step process that we'll be talking about shortly is all tied around these 5 principles. I want to talk about each of these briefly. By policy-driven, we mean that decisions reflect policy goals and objectives of the agency that define desired system condition and performance levels. Generally, these policy goals and objectives are driven by transit agency leadership. They should be embraced by executive management and by the governing board of the transit agency. By performance-based, we mean that there should be established target levels of performance of transit assets and the delivery of services to the public. And this should be the basis for how funding is allocated and how progress is being made in terms of the implementation of the asset management plan. Asset management should evaluate options. It should be examining a comprehensive set of choices and trade-offs, and that becomes the basis for decision-making. Choices should be systematic, and the objective here is to find, again, the optimal allocation of limited funding. Asset management should also be data-driven. Management systems and tools that utilize quality data should be used to support decision-making. So the data is really critical. What we find is that quite often the data may exist, but it never gets analyzed. Or the data may be analyzed, but it's never adequately and completely used to support decision-making. And finally, the 5th principle is asset management should be transparent. Asset management should be supporting decisions that should be suitable for revealing to the public. They should be, again, embraced by executive management and the governing board. So the transparency, both internally and externally, is very important in the implementation of asset management. What does all this mean for you as transit agencies? Ideally, what this means is that asset management provides the basis for optimally deploying or applying the limited financial resources that you have. And we do this to achieve optimal performance, looking at the optimal application of these funds to support both maintenance programs generally supported in the operating budget and renewal and replacement activities generally funded out of the capital budget. There is a growing nexus between, or awareness of the nexus between asset condition and safety, and asset management certainly is supporting the safety initiatives of the industry and individual transit agencies. Most important thing to recognize is that asset management is a process that supports better decision making, and it achieves this through transparency, both within the organization and in presenting the decision making to the public. Particularly important in making the compelling case to secure funding to support infrastructure renewal. And it should be done in the context of recognizing risks in terms of how transportation assets can fail, what the probability and the consequence of failure will be, and we'll be talking about that specific point as we get into the 10-step method. So Scott, I'll turn it over to you to start talking about how to build an asset management plan.
The asset management plan that we're going to be talking about here is the asset management planning process from the International Infrastructure Management Manual and its methodologies. And it consists of 10 steps that Bob and I are going to be trading back and forth as we go through it. We're going to be identifying the main components of the plan, and then we'll talk a little bit about the organizational process for implementing it. The steps are not strictly sequential. We've all been managing assets in the transit industry for many years, and we've been doing pieces of these steps continuously. So we're going through a cyclical improvement process, but I think the steps 1 through 10 do present some sort of logical sequence in terms of building on the information base. What's required for implementation of an asset management plan? Strong executive support, we've mentioned a couple times, buy-in by managers and staff at all levels, and Laura mentioned that all levels of the SEPTA organization were involved in their planning process. A willingness to assess the current situation and improve, that is, being open to change. The flip side of the fact that we've been doing asset management for many years in the industry sometimes prevents us from opening ourselves to new approaches and new methodologies. An interdisciplinary perspective is critical, working across functions in the organization so that finance people, funding people, strategic planning people, capital development people, as well as maintenance and customer service functions are involved and understand the approach that's being taken in asset management and can contribute as necessary to the planning process. And then a sustained multi-year commitment. The graph on the right of this screen shows some stages of maturity in asset management. The red portion is an emphasis on maintenance strategy review, and that's really where I think, if we're honest, most of the U.S. transit industry has been for many years. When we talked about assets systematically and analytically, we were generally dealing in the maintenance world. The next level of sophistication is to really focus on life cycle costing to try to manage life cycle costs and to optimize the life cycle costs. And then the upper portion of this S-curve at the right is a risk-based approach where we can start to take into account major uncertainties, technological uncertainties, development and environmental uncertainties in the management of our assets and optimize the response of the system and the management of the assets based on those uncertainties. The important thing about this graph is that the horizontal axis that measures time is measured in terms of decades, not months or years. To move up this maturity axis requires years and years of commitment to moving in a single direction on asset management. What you see on the screen are the 10 steps. The first 4 are inventory-related steps. Then we talk about quality of service and risk assessment. These are the steps that are probably the most distinguishing aspect of this methodology of asset management from traditional U.S. practices. The setting of quality of service targets particularly plays a unique role in establishing the basis, the fulcrum on which we can leverage and demonstrate the need for the maintenance and capital programs, which are the 7th and 8th steps. The 9th is the funding strategy, ever important in the transit world, and the 10th is the documentation process. With that, I'll turn it over to Bob to talk about the first step.
The first step is to develop a transit asset inventory. Transit agencies should know what the current state of their assets are. Where are they located? What physical condition are they in? What's the maintenance history of these assets? This is really a fundamental part and really has to be the first step in pulling together an asset management plan. We're talking about all physical assets of an agency, vehicles, facilities, both maintenance and passenger facilities, guideway, track, structure, power, signal communications, all the supporting systems, information technology, and as I mentioned, even IT software. All these need to be addressed as part of the asset management plan. A lot of questions come up regarding what is an asset, what's the right level of detail. There really, to date, has not been any consistent standard in terms of what the appropriate level of detail should be, and frankly, in our experience, it really depends on how the data is being used. Generally, maintenance data is at a finer level of detail by vehicle, for example, whereas an asset management plan, which may focus more on the capital side, an entire fleet of vehicles. So all the vehicles purchased from a single manufacturer in a single year might be a line item in the inventory. Quite often a dollar threshold is used as the basis for determining what a line item asset is in an inventory, and we present here what Washington State DOT requires for transit assets that they fund. Those dollar thresholds really vary quite a bit from agency to agency. There's a $5,000 threshold with regard to FTA funded assets, for example. What's important is the level of detail appropriate for the types of decisions that are going to be made? So if a capital program is only going to be focusing on buying or replacing or renewing an entire subfleet of vehicles, then it really isn't important for the supporting information system to address the question at the individual vehicle level, if instead we're talking about buying, say, 100 vehicles. A certain amount of judgment clearly is required here, and an integration of the more detailed information that's captured in maintenance systems with the more aggregate information that might be more appropriate for capital planning. That's something that needs to be done. And contemporary enterprise asset management systems allow for that type of different levels of aggregation to be conveniently addressed. The content of the inventory is relatively straightforward. It's not a lot of individual fields that are absolutely required to assemble an asset inventory. We list the basic components of an inventory here. Think of them as columns in a spreadsheet or fields in a database. But frankly, it could just be lines on an index card. I mean, we've seen in our experience inventories maintained in a variety of formats, literally from index cards to advanced databases. They all accomplish the same objectives. They put all the information together in one place and use that as the foundation for supporting decision making.
So the second step is to assess the condition of the assets, and this is included in the inventory steps. The idea is to keep a current condition rating for all assets. Again, this is a little bit different from sort of legacy practices in the U.S. transit industry, but we found that the organizations that have started this or implemented in at least portions of their perpetual inventories are finding it quite useful. Its purpose is really to be able to discuss assets across classes and groups with a common condition rating, maybe from 1 to 5. That seems to be what we find most typically. Washington State program that Bob showed you just a couple moments ago has a standardized asset management planning process. They use a 100-point scale from 1 to 100. So it's really largely arbitrary currently. The 4 sources of condition rating are indicated. Age is our most common one. We normally just talk about average age of a fleet or how far beyond useful life assets are. But maintenance costs are certainly another aspect of condition and how the maintenance costs are trending. Physical observation can be a good source of the condition rating, and performance and availability data are a good source. And we in the industry have used and have access to all of these data. We haven't systematically recorded them and maintained them in a perpetual inventory. This screen shows a suggested process that came out of the FTA State of Good Repair roundtables that takes these 4 characteristics: age, asset condition, asset performance, and level of maintenance across the top of the columns as 4 aspects of condition, and suggests assigning a 1 to 5 score on each of them. So a 5 on age means brand new or at least 75% of useful life remaining. A 1 on age means the asset is past its useful life. A 5 on level of maintenance means there's no unfunded or deferred maintenance, and a 1 on maintenance means there's a significant backlog. Then physical condition similarly is 5 is like new, 1 is in need of replacement or repair based on physical observation, and asset performance is based on reliability and availability metrics, and 5 says meets or exceeds all these metric standards, and 1 is frequent performance and reliability problems. Then at the bottom of the screen you see an example asset scoring with each of the 4 aspects weighted. So across the bottom are the point scores. 3 for age is weighted 20%, 3 for asset condition is weighted 30%, 2 for asset performance is weighted 30%, and 3 for level of maintenance is weighted 20%. When you do the weighted combination of those, it comes to 2.70, and you'll also see along the right-hand edge of the screen, just for information purposes, the notation that in its national assessment of backlog and state of good repair work, FTA has used a score of 2.50 as identifying a state of good repair. This is just an illustrative process. I think a reasonable way to approach this is to look at this as a fairly comprehensive goal and what you have now in your inventory, and then ask, okay, how can we improve what we have now? What condition rating process could we perpetually maintain for which asset groups using maintenance information that we probably already have but haven't been including in an asset rating of this sort, or reliability information we have but have not been including? And do we want to do a physical observation periodically of the assets? The third step is to determine residual life and include that in the inventory. So again, the idea is the perpetual inventory would continually have updated information about the residual life in each asset. So now you have 100% inventory that for every asset tells you your latest guesstimate as to when it's going to have to be replaced. The graph in the screen shows you one method of addressing useful life, and the economic useful life of an asset is the topic of quite a bit of the 2-day course. The red X's in this screen show failure rates. The illustrative asset group that's being assessed here is public address systems. And the X's were the engineer's estimates of the failure rates for a new generation of public address system being installed. The green declining S-curve is the reliability function based on those failure rates. And so based on a trade-off of the cost of going out and replacing all the remaining TA systems at once at any point in time, or replacing the systems that failed in each year at a higher cost and with a greater consequence in terms of service. A useful life was set of around 10 years, and a program of replacing all of the TA systems in that 2-year period between 9 and 11 years that's indicated on the screen was adopted.
The fourth step is determining life cycle cost. As I mentioned in the definitions, one of the goals of asset management is to optimally apply limited financial resources to achieve a desired level of performance. To do that requires considering not just the cost to acquire the assets, but also the cost to maintain them, typically activities with a cycle length of less than a year that are captured in the operating budget, to renew the assets or rehabilitate the assets, longer cycle activities that are typically captured in the capital budget, and the eventual replacement cost, well, disposal and then replacement cost of the asset. And again, we're looking for the optimal sequence of investments, both on the operating and the capital side, that minimizes this cost in the long term. The components of these costs should reflect what the cost is for the agency to implement the action. And it should include the complete cost, not just the cost paid to a vendor or a contractor, but also include the various soft costs, the professional services costs for design, engineering, project management, construction management, etc. It should reflect current conditions, so it's reasonable to expect that replacing an asset under traffic will be more expensive than originally constructing an asset. So, for example, installing track before services begin is less expensive than placing track once services have already started. The estimation of cost should reflect the impact of technological change. This is certainly true in the case of information technology related communications, control system assets, but other assets as well. It should address the impact of regulatory changes. So the original cost to build a station or a building, for example, designed prior to the advent of the Americans with Disabilities Act will be different based on current requirements, current building codes, and related laws. So the inventory at this point, going through steps 1 through 4, is now complete. We have a complete set of information that addresses the 5 questions that are listed here. All of this becomes the foundation for the remaining 6 steps in the process. If there's any real challenge, then the issue is how to keep this inventory current and complete and accurate. For many agencies, there's a big effort to assemble this information the first time. And then there needs to be a routine established to keep it fresh, keep it current, to reflect assets that are required, to delete assets that are retired, and to best leverage the information that is coming out of the maintenance record keeping.
So quality of service targets are the 5th step, and as I mentioned at the outset, this is probably the respect in which the asset management methodology that we're discussing is most different from traditional U.S. practice. The concept of this method is that quality of service targets, and sometimes the methodology calls it a quality of service agreement, which I think is a little more representative, that the agency enters into an agreement with its public as to the quality of service that can be afforded. And it's usually expressed and monitored in terms of fairly traditional measures, miles between road calls, for example, or the amount of downtime. The availability of an asset is probably the most generic measure of quality of service, and you see elevator system availability illustrated on the screen. It's one that we generally have very good data for. Many systems contract out their elevator maintenance or their escalator maintenance, and they build this literally as an agreement into their contract with their vendors to manage the assets to a certain level of availability. And you can see how the availability of the WMATA elevators here were tracked over 2009, 2010, and then how a horizontal line for an agreement level of maintenance can be reached. But the overall quality of service agreement should include safety factors, and it should include other aspects and other asset groups that may include on-time performance, asset-related on-time performance issues, and distance between failures or time between failures, as well as just availability. Whatever is of material concern in the long run. And these quality of service agreements are often not terribly complex. Major measures like availability, reliability, on-time performance can capture a lot of the quality of service. But then the maintenance and capital programs are analytically based on those quality of service agreements. So unlike our historic practice, more is not always good in terms of quality of service. If you are exceeding the agreed measures of quality of service, you are incurring unnecessary expenditures in this methodology. And there are examples of systems that have, based on their measurement and tracking of condition ratings, decided we're maintaining our buses too well. We're exceeding the quality of service agreement. Just as an ironic kind of side aspect of this quality of service issue. Having talked about quality of service, risk is next.
So the sixth step is addressing risk, or in other words, addressing the impact of the possibility of failure of the assets. The process that we'll describe here is one that is commonly applied in other types of public works. Water utilities in particular are an excellent example of entities that apply this approach. U.S. military uses this approach quite a bit. It generally involves assessing risk along two dimensions. They're using two criteria. Very simply described as what's the likelihood or probability of occurrence of an asset failure, and what's the consequence of the failure in terms of the magnitude of the failure and the length of time over which that failure might be experienced. This is a process that, properly applied, needs to be addressed comprehensively across each asset in the inventory, and the objective of the asset management plan would be to, again, optimally deploy or apply limited financial resources so as to minimize the agency's exposure to risk, and that risk can be interpreted as the simple product of multiplying the likelihood of occurrence times the magnitude of the impact resulting from an asset's failure. And that information, combined with the calculation of life cycle cost and in the context of asset performance, really becomes a fundamental part of developing an asset management plan. This next slide is an example of the type of consideration that is used in determining the relative level of risk associated with an asset. This is a real example from a light rail agency in the U.S. that is considering risk associated with a segment of track. The columns represent the relative severity of the impact of a failure, a derailment in this case, ranging from a catastrophic failure with a cost to the agency of in excess of $10 million to a much less destructive event with costs less than $100,000. And the rows represent the relative likelihood of occurrence from relatively high occurrence, in this case greater than a 1 in 4 chance, to a relatively unlikely occurrence, in this case a less than 1 in 100 chance. And you can see through the color coding here, a rating is applied from 1 to 8, 1 representing low impact, low likelihood, 8 representing high impact, high likelihood. And this information is assessed and determined for each asset in the inventory. Another example, and I don't have a slide for it, but another way this is being applied in the water utility industry, for example, let's say freshwater. Water utilities have information about every piece of underground pipe that they own, its age, its size, its cost, and what the probability of failure at any given time is. They also know the number of households that are served, or businesses that are served by each segment of pipe in the network. So if they know that they have a segment of pipe with, say, given its age and conditions, a 1 in 500 chance of failing, and they know that they're serving, say, 100 households, they can do some simple math to come up with the number of households that could be affected by the failure of that particular asset. And they know that for the entire network of assets that they own. So at this point in the process, we've completed our inventory of assets, we've set our performance targets, we understand the implications of failure of the assets across all the assets that we own. We now get into the process of optimization. And again, we're looking for the best way to apply the limited assets that we have to achieve the desired results, that is, to achieve the performance or service targets that Scott talked about. So we'll start the discussion, or continue the discussion, talking about optimizing operating and maintenance expenditures, and then Scott will follow up talking about the capital side. When we talk about operating and maintenance expenditures, again, we're talking about relatively short cycle activities, generally activities that occur daily, weekly, monthly, semi-annually, quarterly, annually maybe. We're not talking about long cycle activities, like replacing a roof, for example, which might have a 30 or 40-year cycle. Generally, we're talking about looking at the cost for preventive or scheduled maintenance, the abbreviation PM here, versus the cost for corrective or unscheduled maintenance, abbreviated CM here. What we want to identify is what's the cumulative cost for preventive maintenance or scheduled activities versus the cumulative cost for corrective maintenance activities, and find that optimum combination of preventive maintenance plus corrective maintenance. Generally, that's associated with how frequently we're doing the preventive maintenance cycles. And the next slide provides an example of this. In this slide, the horizontal axis represents how often we do a preventive maintenance activity. These can represent thousands of miles or months between inspections. So are we doing the inspections every 1 month, 2 months, 3 months, 4 months, etc.? The blue line represents the business impact, that is the cost of the preventive maintenance activities. The longer the time period, or the larger the number of miles between inspection intervals, the lower the cost over time. So the cost, in this case, for doing inspections every 5, say, months, is significantly higher than the cost for doing inspections every 10 months or 10,000 miles, whatever that horizontal axis represents. The dotted orange line described here as the risk exposure is the cost of corrective maintenance. And what we see, quite predictably, is that the longer the intervals are between preventive maintenance activities, routine inspections, think of it as oil changes in your car, the longer that interval is, the more likely it is that there will be unscheduled maintenance activities. The real question then is, what's the optimal period between inspection intervals? That is not necessarily where these two lines intersect. Instead, it's determined by looking at the sum in each year of the blue line declining downward from the left and the dotted orange line increasing upward to the right. We see that in this slide. For the gray line in any given year is the sum of the cost, say, this year. This value is the sum of this distance plus the sum of this distance. And what we see in this case is that the optimal point is the low point in the curve, or in this case, at 7 months or 7,000 miles.
So step 8 is the second major operating component of the program, the capital investment program. The capital investments are based, again, on optimization or minimization of the life cycle costs of the assets to provide the required level of service, including the capital costs, the maintenance costs, and the rehabilitation and renewal costs. So again, we have here an optimization curve based on the increasing retirement age of an asset. The key aspect of the capital program is when do we replace and when do we overhaul. This method and approach is similar to the one Bob described for maintenance, but applied to the economic useful life. And indeed, it's this kind of methodology that best actually defines the economic useful life of an asset. And I think we should quickly say that most of us have found in our experience that the depreciable life of any given asset, for example, is not necessarily the economic useful life. So these methodologies are really what determine the economic useful life that can minimize the life cycle cost of your asset. On the left-hand vertical axis, you see annualized life cycle cost. And the annualized life cycle cost is like a mortgage payment that will exactly provide all of the maintenance and capital costs that you've estimated are needed over the life cycle of the asset. So it combines capital and operating expenses into one annualized life cycle figure. The horizontal axis in this graph is age, it's not time. So we're looking at the age at which an asset, in this case a vehicle, is retired. So the downward slope on the left side of the graph is illustrating that if we don't keep the asset very long, the annualized life cycle cost is pretty high because we don't have a chance to amortize or use up the capital cost, even taking into account salvage. But over time, we reach some point at which the increasing maintenance and failure costs and the impacts on service of the aging asset start to outpace the declining annualized capital cost of the asset, and at that point is when we reach the minimum life cycle cost. In this case, somewhere on the gold curve, somewhere out in the 11 to 12 year range. The blue curve shows a contrasting strategy, which is to expend less on maintenance in the early years and then undertake a midlife overhaul at about 6 to 7 years. And that's the upward tick in the curve there represents that capital expenditure at the 6 to 7 year point. And in that strategy, the curve on life cycle costs then increases immediately following that investment and reaches a minimum point at a later point in time, somewhere around 15 to 16 years, as the optimal life cycle cost for the retirement of the asset. So again, trading off the increasing maintenance and failure rates over time and finding the point at which they start to outpace the declining capital costs over time gives you the ideal economic useful life of the asset. And now Bob's going to talk about funding strategy.
The ninth step is to take all of this information, the inventory, the performance targets, assessing risk, finding the optimum operating and capital spending, and integrate that into an overall agency financial plan. These are the types of questions that need to be answered. We're quite fortunate in the U.S. transit industry to have a couple of analytical tools available to us that have come about through the recognition of the importance to address these needs, both on the part of FTA and on the part of the Massachusetts Bay Transportation Authority in Boston. The analytical tool that Laura talked about that was applied at SEPTA was a tool that was developed by the MBTA about 12 years ago. It's a tool that AECOM happened to develop it for MBTA. It's actually MBTA's product, which they will make available to the industry, and we'll talk about that a little bit later. They'll make that available at no cost. Similarly, FTA will make its tool called Term Life available at no cost. And the tools were developed to answer these fundamental questions. What's the value of our inventory? What's the size of the backlog? What are the future annual needs? And most importantly, what happens to asset condition if we don't adequately fund those needs on a timely basis? When MBTA was first addressing these issues back in 2002, they had just received from the state legislature dedicated funding. That had happened in 2000. They were receiving 1/5 of a statewide 5% sales tax. They needed to convince the legislature that that funding at the time was sufficient for operations and for infrastructure renewal, but was not sufficient to also expand the system. In answering these questions, they were able to convince the legislature of that reality. And one of the graphics that they presented to the legislature, again, based on the same tool that Laura was applying at SEPTA, they presented this graphic. At the time, the MBTA was able to determine that their backlog, their state of good repair backlog, that is the dollar value of assets that were beyond their useful life, was $2 billion. This was back in 2002, and all the numbers presented here are in 2002 dollars. At the time, the agency was spending about $350 million a year. And analytically, they were able to derive, based on a comprehensive inventory, that the backlog would grow up to $5 billion after 20 years if they kept spending at this level of $350 million a year. What they found through the application of this analytical tool is to maintain the inventory at $2 billion after 20 years, they'd have to increase the spending, so we end up at $2 billion. They'd have to increase the spending from $350 million a year to $450 million a year just to keep the backlog where it is. And to reduce the backlog to zero by a date certain, in this case after 20 years, they'd have to increase the spending even further up to $610 million a year so that the backlog would decline eventually down to zero. And this was compelling information that, in part, was used to convince the legislature to allow the MBTA to continue to use the dedicated funding just for operations and for infrastructure renewal, and to not use that funding to support further expansion of the system.
The last step is the documentation of the asset management plan. This outline on the screen is the major sections suggested by the International Infrastructure Management Manual. The visual on the right is the Ottawa Asset Management Plan. We had to go to the Commonwealth countries to find a transit asset management plan that really incorporated most of these concepts. So they're suggesting that the plan should begin with a background and a description of the services the agency provides, and then a description of the current and targeted conditions of the asset. So that's where this condition rating really comes into play. You can show recent trends in conditions and targets you're setting for changes or improvements in condition. And then the heart of the plan are the program description, the maintenance program description and the capital program description. Then financial requirements and funding strategy, as Bob's just summarized. They suggest performance metrics in a separate section or even an appendix showing trends over time in major performance metrics that the plan is based upon. And then they suggest ending the body of the plan with a commitment to the users to kind of tie a ribbon on the reason for carrying out the plan process. We want to talk now a little bit about organizational implementation aspects of this kind of an asset management planning process. This screen, again, is derived from the International Infrastructure Management Manual suggestion for an asset management planning team. It suggests that the members would be drawn from all of the disciplines involved, the asset managers and maintainers, the finance department, information services. I think you've gotten the notion that information that you can trust, data you can trust is key. And so information technology usually becomes a significant aspect of this asset management planning process. customer services department in terms of customer-related and output-related measures, strategic planning, the safety department, service delivery function. It also suggests that external advisors can be useful in the planning process, and that this team needs to have a relationship with the corporate management team. The top executive team of the organization needs to be involved in the asset management process. The team also needs a sponsor from the executive management team. Maybe the CEO of the organization, may also be a second level executive in the organization, but someone that says that this is the charter of the asset management team, and that with the cooperation of the rest of the corporate management team, we're going to support these folks in implementing asset management methodologies. Here's a list of some of the titles that we typically run into in terms of the functions that are described generically on the previous screen in the transit industry. A pilot is a good idea for beginning asset management. Some people select an asset group. Some people select a particular operating base. Some people will deal with a building complex or a site. But to select a pilot, test the validity of the assumptions of the process, it's a good promotional tool for convincing skeptics in the organization. It can be a seeding operation for training people that can go out and see the asset management efforts in other areas of the organization. And there are lots of examples. I think this is a pretty natural process, but I think the idea is generally that we should begin from where we are and take incremental steps. This next screen shows a flow of incremental steps that could be an annual asset improvement cycle, beginning with an assessment of the current practices and research on best practices, and then deciding what your aspirations and goals are and identifying the gaps between your current practices and the best practices, and then selecting some improvements to be made in the next cycle, whether it's expanding the pilot to another area, whether it's converting some of your inventory to an enterprise asset management system, or other types of improvements in your asset management practices, implementing those. And then off on the right, having an audit and review process, preferably an independent process by somebody from outside the asset management team that feeds back into the renewed cycle of assessing the processes and improving them over time. And I fully expect that FTA's requirements and the industry efforts, as Laura has illustrated, will demonstrate this idea that the journey of several decades begins with a few steps. So to summarize this asset management planning process, you need to focus on current practices and develop a more advanced level over time, moving up that maturity curve. You need to focus on making sure you have top management and policymaker support, and then adjust your plans and processes as you go along through some sort of a plan, do, check, act cycle. And Bob's now going to talk about a case study on capital prioritization.
The context for this case study, it's the San Francisco Municipal Transportation Agency is the agency we're talking about, and they were involved in planning a New Starts project, the Central Subway project, which construction of a largely tunnel extension to the Bayside light rail line, the T3 line that was built about 8 or 10 years ago. That project is now under construction. What we'll be talking about is some of the financial planning that led to the implementation of that project. Very complicated, very expensive project, and a financial plan that needed to demonstrate, as all New Starts financial plans need to demonstrate, that not only could the agency afford to construct and operate the proposed project, but it could also continue to operate and renew the infrastructure supporting existing services. The underlying financial plan, of which the asset management state of good repair analysis was an integral part of, is described in the flowchart that we'll build here. We begin with a financial analysis model which integrates projections of expenses and revenues, both capital and operating. We focus on an underlying asset management analysis which begins with an inventory of assets, very similar to the process that Laura described, which is applied in this case in the context of the state of good repair database that the MBTA developed, our transit asset management model in this case, which applies a set of asset decay functions, which allows us to understand how assets age over time, which projects a set of annual needs, a backlog and annual needs, which flow into the capital uses of funds in the financial plan. We also include not only existing assets, but the proposed new assets, in this case, a 7,000-foot tunnel and associated expansion of rolling stock. And those costs are applied into the financial plan as well. On the operating side, we know what buses and trains will be operated, in the case of San Francisco, what cable cars will be operated, and electric trolley buses will be operated in the system. And that information is applied to an operating and maintenance cost model, which gives us a projection of operating costs over time. We also recognize that as assets age over time, the unit cost to maintain those assets will change over time, so that's addressed in the financial plan as well. On the revenue side, a set of existing and new sources are applied to support both the cost for continuing infrastructure renewal and replacement and the cost for the proposed system expansion. And on the operating revenue side, we have estimates of ridership based on underlying sets of demographics, which also drives some of the capital funding. And the ridership drives fare revenue based on a set of fare assumptions, and then there's some other operating revenues as well. What we're really going to focus on is what's happening inside this dotted line box, an important part of the overall financial planning process. Inside that box, two types of analyses were performed. One type of analysis looked at not applying a funding constraint, just looking at the total needs over time. So assuming no constraint in funding, we apply the assets and the decay functions to the model, and that gives us an estimation of backlog and future needs. And this is exactly the type of information that Laura presented with regard to SEPTA. We apply the model in another mode where we apply a funding constraint. So we have constrained funding, which we apply to the model. We apply the same asset decay curve information, and we recognize that we can't fund all the needs on time fully every year. So we have to make a set of decisions about, well, what do we fund on time and what do we not fund on time? And those decisions are made in the case of San Francisco on the basis of asset age and cost effectiveness. This chart was actually developed in the context of another agency where we were considering seismic and climate change. And a set of project priorities came out of this process. That factor in the middle could also represent operating impact. A set of funded projects emerge after applying the funding constraints. That information is fed into the financial analysis model that we showed in the prior slide, which ends up giving us a financially constrained plan. But we also recognize that by not fully funding all the projects in every year, there will be an impact on future asset condition. And that future asset condition needs to be addressed in terms of the performance of the assets, and a variety of performance measures are addressed, which I'll talk about shortly. In the case of San Francisco, a decision support tool was used to support the determination of priorities of investments. This came out of a consensus building process that identified these 10 decision criteria. Each asset was rated against these criteria. A rating scale was developed for each of the 10 criteria. Here's the definitions that were developed for just one particular criterion. All participants in the rating process, generally people from within the agency with knowledge and understanding of each of the projects to be evaluated, were provided with this set of definitions, this definition for this criterion and some more definitions for the other 9 criteria. And those definitions for each possible rating score, each row in the table, was applied consistently throughout. Again, this is assuring some level of transparency in the process. Here's an excerpt of the inventory in San Francisco. It's very similar in level of detail to the inventory that Laura described for SEPTA. Here's a brief overview of the system-wide assets, $12 or $13 billion worth of assets. A significant portion of those assets, in the case of San Francisco, was for the overhead contact system, which powers the electric trolley bus and light rail system. And you can see the breakdown here of the assets. These overhead contact system assets are broken into these major categories. Very expensive set of assets. The State of Good Repair database then projected what the future needs would be in an unconstrained environment. And we see by asset class, here's the asset classes over here. By asset class, we see the trend in needs each year. This big peak at the beginning reflects the amount of time to address the immediate backlog. The immediate backlog was enormous. More than $2 billion worth of assets that were beyond their useful life. If you will, money fell from heaven. This is as fast as SFMTA could spend the money to fund the backlog, and then in the long term, we see what the annual needs are after the backlog is addressed. The 20-year average is this $510 million a year one. The model was then applied across all of the assets, and a set of projects, a smaller number, were identified. Similar to what Laura described at SEPTA, we took detailed asset line items and rolled them up into larger line items for the purposes of our analysis. So in this particular example, we have a maintenance facility which happened to have all the roof-mounted HVAC equipment and the roof that needed to be addressed at roughly the same time, and just from a constructability standpoint, so we just rent a crane one time rather than a couple of times. We combined these various elements of the building into a single project, single line item for the purposes of the analysis. Identifying capital projects, as I mentioned earlier, addresses some trade-offs in terms of level of detail. Here's some of the points that were made in terms of identifying some of the capital projects in this analysis. The prioritization, again, used a set of evaluation criteria that were applied in the context of a decision support tool, which then effectively rank ordered the projects from most important to least important. And that information, that relative priority from most important to least important, was considered in the context of asset age, that is, the extent to which assets were beyond their useful life, in establishing which assets would get funded on time and which ones would be deferred. I'm going to show you in a couple of slides a set of performance measures, how well the capital assets were performing in the 20-year projection that we developed, and we'll be looking at these various performance measures. The application of the SGR database, the analytical platform for this analysis, addressed considering three different levels of funding, the three different columns in this chart, and three different levels, or three different combinations of consideration of priority score, which comes from the decision support tool using the 10 evaluation criteria, versus consideration of just asset age. We ran some experiments looking at just basing the decision-making on the outcome of the decision support tool, the first row. We ran some experiments looking at ignoring the outcome of the decision support tool and basing the decision-making solely on the basis of age. And then we looked at some experiments where we combined the two. No particular magic to this 50-50 weighting, just happened to be a mix that we looked at. And no particular magic to the particular funding levels that we looked at. The lowest level of funding happened to be what came out of the prior cycle of financial planning. We looked at what would it take to maintain the backlog, what would it take to cut the backlog in half? But again, there's no particular magic to these funding levels that we looked at. You'll recall that stacked bar graph that had a funding level that averaged $510 million a year. The height of those stacked bars is the height of these stacked bars here. We looked at a couple different funding levels. We looked at one funding level that would maintain the backlog where it was. And the backlog started out at about just over $2 billion, and it ends up at about $2 billion, looking at this red line measured against this axis. We looked at a funding level on the left-hand axis at $366 million a year. Everything that is green gets funded on time. Everything that's pink didn't get funded on time. So there's a good part of the backlog that we're not addressing on time in this scenario. Here we see the relative intensity of funding by asset class. Here we see the percentage of assets that are at a state of good repair by asset class. And this dotted black line shows us the overall percentage of assets at a state of good repair. And we're starting out at about 85%, and we're ending up at about 85%. We see along the way some assets perform very well, and some assets really take a dip, particularly toward the end of the analysis period. In this case, these are light rail vehicles that really begin to take a dip. They're starting to need to be replaced toward the end of the analysis period. And at this funding level, we can't fund them all exactly on time. And this graph down here shows the cumulative needs that are funded. And this takes a big dip because we have this big unfunded backlog at the beginning. Eventually it grows over time, and we end up with about 75% of the needs funded over time. So these results are at $366 million a year, which was enough to keep this backlog constant over a 20-year period. I'm going to go to the next slide where we increase the level of funding from 366 to 432. And what do we see happening? I'm going to flip back and forth, and you'll see that what happens is the red line drops from a backlog of greater than $2 billion to a backlog just about cut in half. So by spending this additional funding per year, we're able to cut the backlog down. Slightly more intensive spending. All these lines end up a little bit higher. That's one way to look at the results. Another way to look at the results is to use or to estimate the condition score of the assets using the asset decay curves that are in FTA's term light model. That's FTA's Transit Economic Requirements model that FTA is making available to the industry at no cost. Again, assets are rated on a scale from 5 to 1, where 5 means the asset is brand new and 1 means the asset needs to be replaced. Again, at our lower funding level of $366 million a year, looking across all the various asset classes, we see the trend by asset class over time. We see a couple of asset classes that are actually pretty low at the beginning. But all the asset classes by the end of the analysis period actually are doing okay. They're doing better than 2.5, better than that 2.5 threshold that Scott mentioned earlier. And indeed, the overall condition of the assets starts at about 3.2 and actually ends up at about 3.4. At a higher level of funding, increasing this funding from 366 to, in this case, up to 432, we see that all the lines increase over time. And again, I'll back up just so you can see the difference from the lower level of funding to the higher level of funding. As I mentioned, we looked at different types of decision-making, making the decisions based entirely on age, or basing the decision-making entirely on the basis of the priority scores that came from the decision support tool, and we see some interesting things happening. We see that when the decisions are based 100% on the priority score without consideration of asset age, not a lot of spending is occurring in this asset class, which happens to be stations. And a lot of spending happens to be spent in this asset class, which is motor coaches. As we move the decision-making over to increasingly reliant on asset age and ignoring the priority scores, we see more money being shifted into stations, less money being shifted into, in this case, motor coaches. Now, will these impacts be the same at your agency? Probably not. It will certainly be different, and it will depend on what the condition of the assets are and what the priority scoring is for the projects coming out of potentially an application of a decision support tool tied to the corporate goals of the agency. The compelling argument in the end about the adequacy of, in this case, SFMTA's financial plan is summarized here. We ran 9 experiments, 3 different levels of funding, and 3 different combinations of consideration of priority score versus age. Here's the results from the lower level of funding. Here's the results from what actually we included in the financial plan, and here's the results from the higher level of funding. And we see relatively consistent results, but regardless of which combination of the factors that we're including, particularly for this middle level of funding and more or less for this higher level of funding. A bit more disagreement in the results between consideration of priority score versus consideration of age at the lower level of funding. And again, this will vary from agency to agency. What did we learn from all of this? Well, what we were able to accomplish here is we were able to apply contemporary concepts about asset management into the development of an overall agency financial plan. We were able to demonstrate that the agency could maintain its asset condition and afford to build a fairly expensive expansion of the system. We found that this could be done using readily available tools. It did require some significant effort in assembling the inventory, but this was accomplished. And we were also able to demonstrate that we could look at a variety of performance measures to assure some depth and robustness in the analysis.
All right, so we're going to summarize by talking about a little review of what is transit asset management, the principles, how it can benefit transit, what's required for implementation, how you can get started. The principles are these 5, that it's policy-driven, that you get buy-in from the governance board or the governance level of your organization, possibly even a resolution, but at some point that there be buy-in. We did get a question regarding how you get cultural buy-in and get the renewal projects funded that don't involve a ribbon cutting. But that policy support that's in the top bar of this set of principles is really the key to where that comes from. That the governance of your organization says we support asset management and we are going to prioritize the renewal and replacement projects and the maintenance funding. The second principle is that it's performance-based, that it is based on operating results, and that the analysis that you do is based on your data regarding reliability, regarding on-time performance, regarding asset availability. The third principle that evaluates options, that you evaluate trade-offs using the business and engineering method talked about at the beginning. Choices of maintenance programs of age, replacement age, and economic life, and preventive maintenance intervals based on that analysis. The fourth, that it's data-driven, that you have data you can trust. We talked a little bit about IT systems, but the data collection and maintenance process is critical to being assets, particularly in large numbers. And finally, that it's transparent in the sense that your maintenance program decisions and funding requirements and your capital program decisions and requirements are based on this analysis and data, and anyone from the media to the governing board to policymakers to funding agencies should be able to question any of those decisions and see that it is derived from the service level and the analysis that you've done, and that any deviation from the optimal life cycle cost program will result either in a compromise of the service agreement and the service quality or an increase in cost. So the transparency is a critical principle and to the industry. How else can it help? Well, first of all, if you're doing the analysis to optimize costs in the long run, it can reduce long-run costs for providing the assets that are required for service to meet the required level of service or the state of good repair. Secondly, it will provide more consistent performance. If you're constantly monitoring performance on this quality of service agreement basis and managing to that performance, not to incur unnecessary costs to exceed it, but certainly not to fall short of it, then your performance in the long run in terms of reliability will be more consistent, and the same applies to safety. You can assure more consistent safety over time if you're managing your programs based on safety performance data. It provides better decision making. The transparency that we talked about, which does provide the ability to make the case for funding agencies, and you can take into account using asset management methodologies major risks that were almost imponderable under other methods. What's required for implementation? Strong executive support. Laura, in some of her chat box comments, seconded that idea. Willingness to assess current situation and improve, so an openness to improvements and new methods. Buy-in by managers and staff at all levels in the organizations, and interdisciplinary across all functions in the organizations. And then a sustained multi-year commitment to the improvement process and the optimization goals of asset management. There is no single way to move forward. We're all starting from where we find ourselves. And so the implementation can be incremental and accomplished in stages. You can focus on fully utilizing your existing resources, what you have now, the maintenance data you have now, the reliability and time between failure data that you have now, and building on that. And start by addressing the known gaps between the best practices and what your current practices are. Finally, we have a list of references here. The FCA site is a good source of references. It has a good session on the roundtable that has been held and Laura mentioned. I would also, particularly for rail organizations, suggest a reference from the International Railway Association, which the acronym and the URL uses the French acronym for International Railway Association. It's UIC, and they have an asset management principles guide for infrastructure asset management for rail, which is useful because unlike the other sources of asset management methodology, it deals with the transportation organizations where operations is a major component as opposed to being very capital intensive. This school of thought grew up around highways, then water and power, electrical power infrastructure, and is focused on industries where the big dog in the budget process is the capital program. In our industry and in the railroad industry, we're labor intensive, and capital, while a major issue, does not dominate the scene. And in the International Railway Association work distinguishes operations from capital in their management guidelines.